Let's prepare for the upcoming linear equations test, and we're going to start with question number 1, where we need to solve for this system. And so we need to identify what x is. So the first thing that we're going to do is eliminate x. To do that, what we need to do is multiply a number into each of these equations so that the coefficients are the same, but the sign is the difference. So let's multiply 2 on the top, and let's multiply -5 on the bottom. And when we do that, we know that what happens. We're going to distribute 2 into 5x, and then into -2y, and then into 20, and likewise -5 into 2x, into 3y, and then multiply 5 into 27. And when we do that, 2 times 5 is going to give us 10x, and then 2 times -2y is going to give us, what, -4y. And then finally, 2 times 20 is going to give us +40. Great. -5 times 2x is going to give us -10. Great. So now we can eliminate that in just a moment. -5 times +3 is going to give us -15y equals -5 times 27 is -135. So we know that 10x minus 10x is 0. Those cancel out. -4 minus 15 is going to give us, what? -19y equals 40 minus 135 is going to give us -95. So now we need to do a little inverse operation. We're going to divide both sides by -19. And when we do that, we realize that y is equal to 5. Great. So we figured out what y is, but we still need to determine the value of x. So we're going to take y, which we now know is 5, and we're going to plug it back into the equation. I'll just do it on the top one. So I'm going to do 5x minus 2, open parentheses, equals 20. And then what I know is that in that parentheses, I'm going to pop in the 5. So let's pop in that +5 right there. 5x minus 10 equals 20. And then what we're going to do is we're going to add, of course, 10 to both sides. And then 5x equals 30. And then ultimately, x, when you divide both sides by 5, right? X is going to give us 6. All right, so we figured out the x and we figured out the y value. Great. Let's take a look at question number 2. And I see that we've got 2 equations, each with a couple fractions, and in order to simplify, we need to get the denominators to be the same. And I see that we've got 6. The easiest way to approach this is to multiply this fraction by what to get 6? 2, right? And if we do it to the bottom, we're also going to have to do it to the top. Same thing for this fraction. This fraction right here, of course, 2 times 2 is going to give us 4. We don't want that. We're going to multiply this one by 3, and if we do it to the bottom, we've also got to do it to the top. So let's simplify, and we're going to look at this top fraction right here. So we're going to multiply 2 times a, and that's going to give us 2a over 6 plus a plus b over 6. Great. And then beneath it, we're looking at this side right there. We've got 2 times b is going to give us 2b over 6 minus 3, open parentheses, a minus b, close parentheses, divided by 6. And we can't forget that each of these equations are equal to 3 on the top and 6 on the bottom. Great. So now what we're going to need to do is simplify these a little bit further. So let's shift this over. And very simply, this is going to look like, what? We'll start with the top. So we're looking at 2. We can actually add these because the denominator is the same, right? So we got 2a plus a plus b, great. And then we've got 2b minus 3, open parentheses, a minus b. And each of these are, of course, divided by 6. And, of course, equal to 3 and 6. So let's zoom out a little bit and think about how we need to approach this. So when we're looking at this top equation, 2a plus b is going to give us, very simply, 3a plus b divided by 6 equals to 3. And when we look at the bottom, we're going to have to distribute a little bit. So we've got 2b minus 3a plus 3b, because we're distributing, right? Divided by 6. Okay, so what is that? Equals to 6. Great. So 3b plus 2b is going to give us what? 5b. So now we've got, on the top, 3a plus b divided by 6 equals 3. And on the bottom, we now have negative 3a plus 5b divided by 6 equals to 6. Okay, so what do we do now? What's the next step? We're going to need to eliminate the denominator, and to do that, we're going to multiply this by the bottom fraction, or the bottom equation, by 6 on the left side, and the top by 6. So what I now see is that the 6's cancel out on the left, but if we multiply something on the left, we've got to also do it on the right. So we're going to multiply the right side by 6 on both sides. And what does that look like? So now we have 3a plus b equals 3 times 6 is 18. Great. And now we've got negative 3a plus 5b, and 6 times 6 is going to give us what? 36. So now this is starting to look a little bit more familiar, right? So when we're looking at it, I see that we've got coefficients that are identical with the different signs. We've got a positive and a negative. So 3a minus 3a simply cancels out. b plus 5b is going to give us what? It's going to give us 6b. And 18 plus 36 is going to give us what? 54. We're almost done. We got to divide both sides by 6. And that ultimately is going to give us b being equal to 9. Great. So we figured out what b is. We now got to determine the value of a. So let's go back to the beginning. Wow, we did a whole lot. We're going to return to this very original equation. And we know that b is 9. And so what we could do is we could plug that right into this very first equation. Alternatively, we can plug it in somewhere it's a little bit easier down the line, because we know that fractions are a little bit tricky. We could actually go all the way to, actually let's go to this previous step. We can use this one right here. So we know that 3a plus b equals 18. Let's plug the value of b into right here. So to do that, let's write it like this. We need to figure out what a is. So 3a plus 9, because we know 9 is now the value of b, equals 18. If we subtract 9 from both sides, we've got 3a equals 9. If we now divide both sides by 3, a is going to be 3. Wow. Alright, so we figured out the value of both a and b. Tremendous. Let's take a look at question 1c. And again, we've got two equations, and here we've got a couple fractions. So what we're going to do is need to eliminate the denominator. To do that, when we're looking at the top equation, we're going to need to multiply 3 into each of these terms, and in the bottom, we're going to have to multiply again by the value of the denominator, which is 5. So let's simplify that together. 3 times a, and that's going to give us 3a minus what? 2b equals to what? 12. Great. And then on the bottom, the 5's of course cancel out, and we're left with 3a plus 5b. Great. And 5 times 15 is what? 75. Beautiful. So now this is starting to look a little bit like an elimination problem, and to do this though successfully, we're going to need to multiply one of these equations by a negative, or a -1. And so what is that going to look like? All of a sudden, I'm going to rewrite this. So the top is good to go. -1 times 3a is -3a minus 5b equals -75. All right. So 3a minus 3a cancels out. Beautiful. 2b minus 5b is going to give us -7b. And -75 plus 12 is going to give us -63. All right, so we're pretty close to determining the value of b. We're going to divide both sides by -7. And when we do, the value of b is going to be what? +9. Great. So now what we're going to need to do is plug 9 back into one of these equations. And what would be the best one or the easiest one? We can just do this top one right there. So I see 3a minus 2, open parentheses, 9, close parentheses, equals 12. Great. And we've got 3a minus 18 equals 12. Now we're going to need to add 18 to both sides. Beautiful. And I know that 3a is now equal to 30, and if we divide both sides by 3, a all of a sudden is equal to 10. Beautiful. Found the value of a and b. Great. Question number 5 says, solve the systems by using substitution. So let's take a look at each of these. We're using substitution, meaning that we're going to have to isolate a variable. And let's isolate this x. To do that, we're going to get rid of this 2y by subtracting it from both sides. And now I know that 2y minus 2y is a whole lot of nothing. And we now know that x equals 7 minus 2y. What I'm doing now is I'm going to take this value, right, x equals this, and I'm going to plug it in right here. So that's going to look a little something like, open parentheses, 7 minus 2y minus, and now I'm simply, again, rewriting this equation down here, minus y equals -8. We're going to have to combine like terms, so now we've got 7 minus 3y equals -8. And what we're going to need to do now is to isolate this y. We're going to subtract 7 from both sides. 7's, of course, cancel out, and we're left with -3y equals -15. So close. We're going to need to divide both sides by -3. And when you do, y is going to be what? +5. Great. So we still need to figure out the value of x. We got to plug it into one of these equations. What we can do is simply, we'll do whatever. X minus 5 equals -8. We're plugging it into this equation right here. Let's add 5 to both sides. And when we do, that's going to give us ultimately x being equal to -3. All right, so we just solved this systems using substitution. Great. Let's take a look at question number 6. Mrs. Jones, she bought 2 pounds of veal and 3 pounds of pork for $20. Mr. Cook paid $11.25 for 1 pound of veal, 2 pounds of pork. What we need to do is find the price of a pound of veal and the price of a pound of pork, and we're going to use P and V to represent that. So what are the equations that we're going to be working with? So Mrs. Jones, all right, she bought 2 pounds of veal, so I'm going to write that like 2 pounds of veal and 3 pounds of pork for $20. I'm going to write that like 2 pounds of veal. I can write simply 2V plus what? 3 pounds of pork. And how much did she pay? She paid $20. We'll make that equal to $20. I see that Mr. Cook paid $11.25, so I'll write that right here. Right, $11.25, and he bought 1 pound of veal. And this dude bought 2 pounds of pork. Great, so now what we're going to need to do is approach this the way we've been approaching basically any other problem, and we'll do elimination. So what would be the best way? Let's eliminate v's first, right? And I think the easiest way to do that is to multiply the bottom by -2. And when we do, we're going to get, and actually let me rewrite the top equation first. And so now we're going to need to distribute -2 into 1v, 2p, and 1125. And I know that -2 times 1v is going to give us -2v. It's going to give us -4p. Sorry. Oops. 4p. And finally, 1125 times -2 is going to give us -2250. Great. So now we're going to simply combine like terms, and I know that 2v minus 2v cancels out, and we've got 3p minus 4p. That's going to give us what? That's going to give us -1p, or -p, and 20 minus -2250 is going to give us -$2.50. And I know that if we both divide both sides by -1, that's going to leave us with a pound of pork being $2.50 per pound. Great. So now what we need to do, and that's crucial, right? Now we've got to figure out the pound of veal. So what we can do is we can simply plug that value in to one of these equations, and we'll plug it into, so now we need to plug the value of p, 2.5, into one of these equations. Let's do v plus 2p equals 11.25. And I'm going to rewrite that right here. So 1 pound of veal plus 2p, which we now know is, the value of p, of course, is 2.5, equals 11.25. Great. It's almost done. Great. 2.5 times 2 is going to give us 5. So we've got veal plus 5 equals 11.25. We're going to need to obviously subtract 5 from both sides. And when we do that, veal is equal to 6.25. So the price per pound of pork is $2.50. The veal is a little bit more expensive, actually almost three times as much, at $6.25.